Hello everybody, welcome to my YouTube channel Data Speaks. This is Ishwar Basal. In this video, we are going to talk about data science, machine learning, and artificial intelligence. We will introduce the topic of data science and machine learning by understanding what exactly is the data science. How do we perform the machine learning models? What are the different types and techniques of data science and machine learning? What are the different types of data sources that is required to do the machine learning models? What are the different tools and techniques that is utilized in data science and machine learning projects? Once you have developed your data science and machine learning models, where and how do you deploy them so that your business customers can utilize it to make the smart business decisions, driving business to be successful? If those are the questions that you are trying to answer today, then you are in the right video. Please watch this video until the end so that you have a complete idea about how does exactly the data science and machine learning model lifecycle look like from the problem discovery up to the deployment of the machine learning models. Not only that, but also I have included what are my next tutorial videos that give you the complete idea about each individual machine learning models that are the backbone of data science and artificial intelligence. So please do not forget to subscribe my YouTube channel for future amazing videos that can help you to grow in the world of data science and artificial intelligence, and you do not miss out any information that I'm sharing in this YouTube channel. So let's continue and get started. Now, to begin with, let's start understanding what is the data science, what is the machine learning. That is something, the very foundational level information you gotta be understanding. That being said, the data science is an interdisciplinary field. That being said, it uses many different disciplines of learning, many different disciplines of the research that we need to do, that uses scientific methods and processes, techniques, algorithms, and systems. Basically, it uses some kind of software and hardware systems to extract the knowledge and insights from the structured and also the unstructured data. In the real world scenario, there are many different types and structures of the data. The data in the real world cannot be expected to be really great and ready to analyze. So that being said, data can be a big mess, big unstructured, and sometimes structured as well. So it combines the aspects or disciplines of statistics, computer science, and domain expertise. And after having all of those bunch of disciplinary knowledge, then you can start analyzing and interpreting the results from those complex data. That is the high level introduction about data science. Now, next we will understand is what is the machine learning then. The machine learning is the subset of artificial intelligence. So it is one thing is human intelligence, that is the biological intelligence. Now here we are creating the artificial intelligence. We're building the intelligence, and that involves the use of algorithms and statistical model. We just talked about the statistical models in the data science explanation. Similar way, in the machine learning, we use the statistical models to enable computers to learn from the data and make predictions or decisions based on the findings from the data. The most important feature about the machine learning is being able to train themselves using the data, being able to learn themselves. That being said, who is themselves? The machine learning models. The machine learning models is developed in the way that when it is trained with available resources, available data, then the machine learning models learn by themselves so that they can improve the performance on the specific task for which the training is happening over the time without being explicitly programmed for that specific problem. That being said, machine learning algorithms are trained in the way that they can learn themselves about the trends and about the structures of the data, and over the time as they keep learning, they keep improving on the capacity of making predictions. That's the main special characteristics about the machine learning algorithms and machine learning models. In this video, we have been talking about what is data science, machine learning, and artificial intelligence, how they are being developed, they use the different interdisciplinary field and so on. But even before that, we need to understand one thing. That is, why do we need to do the data science and machine learning within an organization? That being said, the data science and machine learning transform your organization's raw data into the actionable insights that help you to make the strong business decisions that drive you towards the success. These interdisciplinary field of data science and machine learning help and enable organizations to identify the hidden patterns and trends in their data and help to automate many complex tasks, like some of the examples: predicting customer behavior, detecting fraud, predicting stock prices, and predicting if a patient is going to have a certain disease based on the different symptoms that is collected through the data. These are just a few examples of many different applications across various industries, from automotive to aviation, from healthcare to pharmaceutical, from finance to stock market, and so on and so forth. It enhances the productivity and it personalizes the user experiences, which fosters data driven cultures by enhancing customer satisfaction and revenue growth. As we know that in today's world, the size, volume, and the complexity of the data is exponentially growing. So the opportunity to do the advanced data science, machine learning, and artificial intelligence is as well. So that it gives a competitive advantage and it helps us to solve very challenging real world problem and helps businesses, industries to grow forward and become successful. By now, we have understood what's and whys of data science and machine learning, and we have understood why it is important. But isn't it so important to understand what is required to make the data science project successful? We need to understand what exactly are the key considerations or key requirements to do a successful data science project. Let's understand those one by one. Before beginning any machine learning or data science projects, you have to know what exactly the problem you are trying to solve using the data science and machine learning project. That being said, you have to clearly understand what exactly is the objective out of this data science project and what goals you want to achieve, what problem you are trying to solve. Next is the quantity and the quality of the data. If you do not have enough quantity of the data or the good quality data, in the beginning you may not have a good quality data. You may have to prepare the data. However, you need to know, if you prepare the data, you will have a good quality of the data that can feed into the machine learning model and it can produce the good accurate results. That's what you have to ensure that you have within your organization, and then you will be able to confidently start the data science and machine learning projects. That being said, all the projects are not guaranteed to be successful. However, there should be an surety that you can take enough effort with the help of the quality and enough quantity of the data that you can achieve the goals that you want to achieve. You can solve the problem that you are trying to solve. So that's one thing you may want to ensure before beginning a data science project. And the next thing is, you have to make sure that you do enough and robust amount of data exploration and you understand the in and outs about the data, about your business. That being said, before you can think of the machine learning models, you need to ensure that you have got enough understanding about the data. That being said, if you do not know the data, then you cannot build the solution out of the data, right? So you have to understand the data at each individual column level and row level. You cannot go at each individual rows and columns. However, it is necessary that you do build enough statistical visualization, statistical exploration. There are many different ways that you can understand, you can explore the data: statistical description, probability distribution, histogram, bar chart, scatter plot, swarm plot, and the correlation heat map, and so on and so forth. So make sure that you understand in and out about the data. You understand what does your data tell you. By doing that, you will first be able to understand the data. Next most important thing that you will achieve by doing the data exploration is that if there is any problem with the data, if the data distribution for the numerical column is normally distributed, or it has a huge amount of outliers that is not normally distributed, right? Those things you will need to understand. If there is a missing values in the data, if there are outliers in the data, anomalies in the data, so those things would be, it is possible to know those things with the help of data exploration, data visualization, and then only you will be able to proceed confidently that you can build some solution out of the data that you have in your hand. Now, once after understanding the data, then you will need to be able to select a right machine learning model or right machine learning models. That being said, to solve a specific problem, you don't need to train all the machine learning models, right? In the next videos, we have talked about every single machine learning models in detail. However, we are talking here about what machine learning model is the best right fit for your problem that you are trying to solve. For example, you want to classify if customer is going to churn or customer is going to stop using your company's services, or customer is going to continue using your company's products. If you are predicting that, you need to make sure that you are using right classification machine learning models. If you are trying to predict the stock prices for tomorrow, day after tomorrow, and so on, then you need to be able to select the right regression type of machine learning models. If you are trying to create the segments, create the grouping out of your unstructured or unsupervised data where you don't have the target variable, then you need to be able to select the right clustering algorithms. If you're trying to reduce the dimensionality out of the data, or you want to reduce the dimensions without losing much of the information, then you need to be able to choose the right dimensionality reduction techniques, for example, principal component analysis, and so on. So that being said, you need to first understand what problem you are trying to solve, and the next would be, after understanding the data, then you have to be able to understand what is the right machine learning model, or what are the right machine learning models that will help you to solve a specific problem. Next is going to be model training and evaluation. You need to be able to train the machine learning model with enough compute power that you have in your machine, maybe your computer, maybe your organizational cloud infrastructure, and so on. You have to train the machine learning models with enough amount of data and enough good quality of the data. Then after models are trained, you need to be able to effectively evaluate your machine learning models so that they are accurate. Evaluation comes in the picture that you have trained the machine learning models, but are your machine learning models be able to generalize in the unseen data? You will train the machine learning models with your training data, with your training the target variable that you want to predict, and you are now later you are testing the capability of the machine learning model, looking at if the model is able to generalize on the unseen data without much overfitting. That's the reason you will need to evaluate that. Or even, it has model understood the data, the training accuracy, right? So if your model has a huge bias, or model is not able to give good accuracy on the training data, then it is the problem of the underfitting or bias problem. We have talked about overfitting, underfitting in our next video that is in the channel. However, here just a high level idea that you need to be able to evaluate the machine learning model effectively, model's accuracy, model's generalizability. That's the reason that you need to be effectively able to evaluate the performance of the machine learning model on training and the test set. Now, say If you have not got the expected accuracy out of the model, then the next comes to the model tuning and optimization. That being said, you need to be able to get the good accuracy or acceptable accuracy that you are trying to get out of the machine learning model. That being said, if you have not got that accuracy, then you need to tune the hyperparameters in the models. You need to be able to set the hyperparameters in the way that models accuracy increases or performance increases. There are many different techniques of hyperparameter tuning, cross validation, grid search cross validation, and so on and so forth. You have to perform that if you have not achieved the accuracy either on training accuracy or testing accuracy, or you have an overfitting problem or underfitting problem, and so on and so forth. So these are the most important factors you will need to take into account while training, evaluating, and tuning your machine learning models. Once the model is well trained and you have evaluated from all different aspects and your model is well fine tuned and optimized, now the model has to be deployed to the production. It is good time to let the business users, business stakeholders use your machine learning model and make the strong business decisions so that it helps them to drive the business towards success by utilizing the predictions that your machine learning model has done. So, that being said, it is important that you deploy in the organizational portal or whatever the tool that business uses, you deploy there and you can help them to make the strong business decisions out of the data. That is called data driven business decisions, and those decisions are really powerful, really accurate, and helps the organization to grow and compete in this competitive world. Once you deploy the machine learning model into the production, you also want to make sure that you are monitoring the performance of the machine learning model into the production, because as the data changes, new data comes in, there might be some errors, some issues that model may not be able to accommodate, and it may throw some error. So you want to make sure that the model does not have any issues into the production, and also it is giving the relevant and most accurate predictions to the business users so that they can continue to make the strong business decisions. Once the model is deployed into the production and you are monitoring the performance of the model, then you may notice that after some time, models' accuracy may degrade, models' predictions may be no more relevant. The reason behind it, because the data may change over the time, business process may change over the time, so that you want to make sure that your model is retrained over some period of time so that your model's accuracy and predictions are still relevant and business can rely to make the decisions based on the current situation, not for the farther away in the history but in the current situation. That is why you need to retrain the machine learning model with the most relevant data, most recent data over some period of time, and that is called model retraining. I have included that video as well into my next videos, other videos in my YouTube channel. Please do not forget to check those. As you start a machine learning and data science project, it is really essential to consider the ethical implications at every single stages of the data science and machine learning project. That being said, it starts with the data collection, ensuring that you have the consent and protect the privacy. Next, when the training the machine learning models, we need to be mindful of the biases in the data that could lead to unfair outcomes, and we must actively work to minimize them. Transparency is the key here. We should be able to explain how our models make decisions, especially in the areas like healthcare or even finance, where trust is the most critical. Once deployed, it's important to clarify who is accountable for models' decision and impacts. Even after deployment, the work isn't over. The model need continuous monitoring to ensure that they remain fair and accurate over time. Ethical practices should be woven into every step, ensuring that our technology serves everyone responsibly and very fairly. That being said, these are the factors that we need to always take into account, from understanding what problem we are trying to solve up to the ethical considerations of our machine learning and data science projects. Now, the next I want to talk about something very absolutely fundamental to the data science and machine learning project, that is the importance of good quality data. You see, the data is the backbone of any analytical project. High quality data ensures that the insights we drive are accurate and very reliable. If the data is flawed or incomplete or biased, it doesn't matter how advanced our algorithms are. The results will be definitely misleading and dangerous for the decision making process in the business. Think of this way: building a model on poor data is like constructing a house on shaky foundation. It might stand for a while, but it's bound to fail when put to the test. Good quality data helps in improving models' accuracy, reducing bias. By the meaning of reducing bias is simply helping the machine learning model to learn accurately from the data that we have provided. Now, of course, it saves a lot of time and resources. That means we don't have to waste a lot of time finding out what exactly went wrong when the model has not done a great job. So, before diving into the next big project, take a time to collect, clean, and validate your data. It's not most glamorous part of the job, but it's absolutely critical for the success of any data science and machine learning project. When we are talking about a good quality data, how we cannot think of from where to collect those data to do the advanced machine learning and data science projects. So this is what we are going to talk about, is where we get the data from. What is the source of the data? The very first source of the data we can think of is the company database, or internal company data, or internal company information. That being said, when a company runs the business, they store the information, they store the data, day to day transactions, and so on. So these data are of any format, including the Excel sheets, Word documents, or databases if they use maybe cloud database or on-prem databases, and so on and so forth. That can be many different sources of the data that company can store and can utilize whenever necessary. The next thing we can think about is online marketplaces. The data is made ready and available to buy on the online marketplaces, and that is sold by many big reputed firms and organizations. For example, you can buy the data from Google, you can buy data from Microsoft, you can buy data from weather.com, and so on and so forth. For example, a Snowflake, that is the very popular cloud database service, cloud database and data warehouse company that sells the data as it's part of the online marketplace. There are many hundreds and thousands of different online marketplaces from where company can buy the data and utilize that for the internal analytical projects. Now, it is the most popular data source, which is called social media. We cannot think of any data scientist or data analyst that may not have used the Twitter data for sentiment analysis when they are entering to data science and data analytical world. Now, Facebook, Twitter, or Instagram, Amazon, and so on and so forth, these are the sources. Or even think about the YouTube video. These are the sources we take the data from. We use API and we pull the data from these online social media, and we extract the data and clean them and do some kind of text analytics, or maybe some sort of chatbot, or maybe some sort of the customer sentiment analysis, or any sentiment analysis, and so on and so forth, right? So that's the one of the most popular one, and I guess everybody must have used the social media data to start the data science and data analytical practice when they're entering into the world of data science. Now, web scraping. Nobody can not think of web scraping. Web scraping is one of the most popular practice to do in data science projects, in not only just for practice but also even in the organizational level. We use the API and scrape the large amount of data and build some sort of the customer sentiment analysis or chatbot or any sort of things by using the large scope of the data, large, data warehouse, some sort of things that it's called the bag of words and so on. So we do the web scraping to extract the information that we need to develop a data science and machine learning project, even maybe individual personal level or the college projects or any organizational level project at some medium to large scale. Now, open source repository databases, or think of the public records or reports. So now this has been one of the most popular as well. So when we think about the data, when we think about practicing the data science and machine learning project, first thing we can think of is the kaggle.com or github.com. So kaggle.com is the platform where many data scientists throughout the world come together in this website and work on the real world practices data science projects. They either compete for a prize or they do just for their practice or their hobby. So they do compete on the Kaggle projects, and they get to practice a lot and learn a lot from other expert data scientists, experienced people throughout the world. So kaggle.com is the platform where a company, an organization, puts a competition, data science problem competition, where every single person has ability to work on that, get the data, and start working on the notebook that is provided within the Kaggle platform itself. And once they do some work, they can look at others work and see where they stand, and later they can submit for winning the prize. They have some sort of this scoring methodology. So once they do some sort of scoring, they will be able to be in specific rank, and if their work is really recognized and highest voted and so on, they may win some prizes, or their work can be visible throughout the community of data science and data analysts throughout the world. And there is a huge opportunity to be contacted, and you may end up getting a big paying job because you have done great job in Kaggle. Now, GitHub on the other side is the platform where you can deploy your code and save it in a repository. You can showcase your work. Many of the time, if you apply for a job in any company, a company asks for your GitHub account and maybe your LinkedIn account, GitHub account, so on, where you will be showing off your work by publishing your own notebooks, your own work, and later you can give just link to somebody. They can access your work and see how you have done, and you can impress the recruiter and HR or data science managers who are recruiting a data scientist for their organization. So GitHub is not only to publish your work, but also you can access others' work in the GitHub. So for example, you want to get a good amount of the sample example workbooks that may help you to do some sort of projects, then you can access the hundreds and thousands of notebooks, thousands of codes from GitHub, and do your practice and learn about it, and then get better every single time. Now, UCI machine learning repository is another source of the data. So here, University of California, Irvine has created the machine learning repository for this is specifically the data source from where you can freely download the data and you do your practice of machine learning and data science projects. When you're learning, when you want to test some concept or some algorithms, this can be the best place to start with to get the data and start working on your machine learning and data science projects. Now, logs and machine data. Of course, when you're working on the manufacturing plants, when you're working on some sort of production plants or production company, then they have the machine log. So machine log can be used in such a way that you are building a machine learning project where you will be looking at if a machine fails to perform a specific job, or what is the likelihood or probability of a machine A failing to run on a specific time or not being able to produce up to the mark, and so on and so forth. That can be, you can the system monitors and records the data of the machine's performance, and you can use that data to build the predictive algorithms, and you can then predict for the future if there is any likelihood of a machine failing to do the production job. So that can be something interesting to use and do the machine learning projects. Scientific research data, of course, is one of the way to use the data. So for example, many of the scientific scientists, or maybe any sort of scientist, right, not only data scientists but also physics scientists or any pharmaceutical medical field medical scientist and so on, they do a lot of scientific research, and they publish the papers, they publish the data information you can utilize and do the machine learning. And it's going to be again another exciting source of the data to utilize and do your practice of the machine learning projects. Experiments and trials, for example, the recent information that you can use of the experiment and trial is COVID-19 vaccine. There were so many thousands and thousands of volunteers who volunteered to take the first shot of COVID-19 vaccine that was produced by many popular companies like Moderna, Pfizer, and so on. They agreed to be the volunteer, and you can take that data, and if provided, and you can do some sort of the predictive algorithms. You can develop a predictive algorithms to say, hey, what was the efficiency of the vaccine on preventing a patient from being hospitalized and so on, right? So you can use that experiment trial data as provided by hiding the volunteers PII, personal identifiable information data, and you can do experiments, you can do some sort of machine learning algorithms, and you can build a machine learning models that can predict the future capability of a vaccine's effectiveness, and that can help the pharmaceutical industry company to further advance or make the vaccines better for the effectiveness purpose. So that's a really good use case of the data that comes from the experiments and trials. Now, cloud storage is something the data you may want to use. Cloud storage data can be the marketplace free tier available data that is provided by some sort of cloud companies, say Oracle or Snowflake, Hadoop, and so on. They store the data and they make it available at some capacity for the online users or data scientists in a downloadable data source, and you can do practices from those data as well. Now, the next I can think of is surveys and questionnaires. Surveys and questionnaires are something that you may want to ask the end users about some the product feedback or services feedback and so on. You can ask about questions about what are your thoughts about the the climate change, or any political opinions about a political leaders think about the recent happening, the upcoming elections, about the president, United States presidents, Kamala Harris or Donald Trump, and so on. You can ask questions and gather the feedback and build some kind of the sentiment analysis or predictive machine learning model that helps to predict who is going to be the winner, or the future upcoming president of the United States of America. So that can be something, surveys and questionnaires will help you to gather the data and do your fascinating type of the machine learning and data science project. API, as I said, there are many different ways that you can extract the data from different websites and social media platforms. Think about the Facebook, Amazon, or Twitter, GitHub, and so on. You can utilize the API, the application programming interface, that can help you to extract the data and safely and do your machine learning and data science projects as you are interested to work on those things. Now we have understood what are the different sources, what are the different places from where we can get the data. However, is it not important to understand what are the different types of the data that we are receiving from those sources. Definitely, we need to have a good understanding about the data so that you can do necessary data transformation, data cleansing on those machine learning and data science projects using the data sources that you have imported from the relevant sources. Now, very first thing we want to talk about on the types of data is the qualitative data. There are two major type of data. One is qualitative data and the next is the quantitative data. We are going to talk about the quantitative data after this. Let's for now understand what is the qualitative data. The qualitative data in simple term is refers to the non-numeric information that describes the qualities or the characteristics. It's used to categorize things based on attributes such as color, gender, or education level, for example. Unlike the quantitative data, which deals with the numbers and measurements, qualitative data focuses on descriptions and distinctions within the categories. Now, would also like to talk about what are the different types of the qualitative data that we are mentioning here. The first one we want to talk about is the nominal data here. Nominal data purely is the categorical data and has no inherent order or ranking. So basically, that being said, on the nominal data, you cannot see any ranking or any orders on that. So, for example, the nominal data can be considered the gender, male and female. There is no order on male and female, right? And we can think about any different types of fruit, for example, banana, apples, grapes, oranges, and so on. There is no hierarchy. Apple does not come before orange, or orange does not come before and after banana, and so on. Different colors: red, green, blue, black, and so on. Now we can think about another example is nationality of a person, like American, Mexican, Canadian, European. The main idea behind is nominal data is more about the categorical data, which does not have any specific order or ranking. Now, on the ordinal data, you can think of is the opposite of nominal data. You can see by the word itself, ordinal data, which is the categorical data itself, but with a meaningful inherent order or ranking. For example, you can think of the education level: high school, bachelor's degree, master's degree, PhD, and so on. We know that the PhD comes after the master's degree comes after the bachelor's degree comes after the high school, and so on. There is a order, there is a ranking of education system. We can also think of some sort of rating, right? Survey rating. We can think of or service quality: excellent service quality, good service quality, fair or poor service quality, and so on. That can be one of the example of ordinal data. They have some sort of ranking, some sort of orders when we look at the data, and we can understand what type of data that is, and according to that we can convert the text or categories into the numerical format, and our machine learning models can accordingly treat them and get trained on that data to do the future predictions. So this is a high level walkthrough on different type of qualitative data, and next we are going to talk about is the quantitative data. That is the other type of data that is really important, and that is the most used in the data science and data analytics projects. So what is basically the quantitative data? The quantitative data refers to the numerical information that can be counted or measured. It's all about the quantities and the amounts. Unlike the qualitative data, which deals with the characteristics and categories, quantitative data focuses on the numbers and the measurements. Things like height, weight, time, quantities, and so on. These kind of data can be used for calculations and statistical analysis, which makes it essential for almost all the fields of like research, science, data analysis, and so on. Let's now break down two main types of the quantitative data, which is discrete here and the continuous data. First, we have the discrete data. This type of data consists of distinct, separate values that can be counted. Each value is unique and there is a no in between. It's either this or that. Example can include the number of students in the class, number of the cars the park in the parking lot, or number of products sold in each year. The key idea is that discrete data represents the countable quantities. On the other hand, we have the continuous data. This type of data can take any value within the range and can be measured with great precision. Continuous data is usually the result of measurements and it can have infinite number of possible values. Examples can include a person's height or weight or temperature reading in Celsius or Fahrenheit, the duration of an event in seconds or minutes, or distances measured in kilometers or miles, etc. Essentially, continuous data gives us the detailed view of infinite precision between two data points, two values. To summarize, discrete data is all about counting distinct or item or values, while continuous data involves measurement that can take on any values within the specific range. Okay, so we have discussed a lot about the different types of the data, different sources of the data, background about the machine learning, data science, and artificial intelligence, etc. Now, this is great time to get started and understand the in and out about the machine learning models. However, this is going to be the introductory level, but we will understand what are the different types of machine learning model, how to get started on the machine learning and data science projects, how to deploy them into the production, what are the different tools and techniques that is being used into the data science and machine learning projects, etc., and the next steps that we will be taking towards mastering into the data science and machine learning models. So without any further delay, let's get started. Let's start by understanding what are the different types of machine learning. The very first type of machine learning we are going to talk about is the supervised machine learning or supervised learning. Supervised machine learning is powerful type of machine learning where the model is trained on labeled data. This means the input data already has the correct answers or labels attached to it. The goal is for the model to learn the relationship between the input and the output so that it can make accurate predictions when given new unseen data. Think of it as teaching a computer to recognize things based on the examples we give it. Supervised learning is commonly divided into two types. First one is classification and the second is regression. In classification task, the model learns to recognize data into specific groups. For example, spam detection specifies emails as either that is spam or not spam. Facial recognition software identifies people in images, and medical diagnostic tools classify whether a tumor is malignant or benign. These examples show how classification can group data into different categories based on the pattern on the model that learns from the labeled data. On the other hand, the regression is used when we want to predict continuous values. For instance, predicting house prices based on features like size and location, forecasting stock prices, or estimating a car's fuel efficiency are all the examples of regression tasks. In these cases, the model learns the relationship between input factors and the continuous output, such as a price or measurement, allowing it to make predictions for new labels or new data points. The next type of machine learning we will talk about is unsupervised machine learning or unsupervised learning. Unlike supervised learning, unsupervised learning works without predefined labels or categories. The goal here is for the algorithm to discover hidden pattern or intrinsic structures within the data by itself. Now, unsupervised learning analyzes and interprets the data without any prior labels. The algorithm is given raw data, raw unlabeled, specifically unlabeled data, and its task is to group or organize this data into the meaningful and the structured way. The common techniques include clustering, where the algorithm groups the similar data points together, and the dimensionality reduction, which simplifies the data by reducing the number of features while retaining the most essential information. Now, clustering is widely used on many real world applications. One of the example can be the customer segmentation, where businesses group customers based on the similar behaviors for targeted marketing. In anomaly detection, unsupervised learning identifies unusual patterns in the data, like detecting fraud in banking transactions, credit card transactions, etc. Another use case is in the data visualization, where the large data sets are simplified for easier analysis, allowing us to see insights that they were not seen previously. Now, the unsupervised learning is an essential tool for discovering pattern in the complex data sets where no prior knowledge exists. It's used in the field like e-commerce, finance, healthcare, and many more to enable the smarter and data-driven decisions. Now, the last but not least type of machine learning is reinforcement learning. Reinforcement learning is a very fascinating area of machine learning where an agent learns to make decisions by interacting with its environment and receiving feedback in the form of rewards or penalties. Unlike supervised learning, which works by with the fixed datasets, reinforcement learning is all about trial and error. The agent performs actions and based on the outcomes, whether positive or negative, it adjusts its strategy to maximize the rewards over time. Think of it like teaching a robot to navigate a maze. At first, it might bump into the walls, but after enough tries, it learns the best path to reach its goal by receiving rewards for the right moves and penalties for the wrong ones. Including all previous ones, this type of machine learning also has endless potential and it's been already being used in fields like robotics, where robots learn to walk or perform complex tasks. In gaming, it's applied in AI to create the smarter opponents that learn how to beat you, like how Google's AlphaGo learns to play and win against the human players. Additionally, reinforcement learning plays a huge role in autonomous vehicles, helping them to make a real-time driving decisions in unpredictable environments. It's a powerful tool that adapts and improves over time, making it ideal for dynamic and complex tasks where the right answer isn't always known from the start. The possibilities here are immense, from optimizing supply chains to create more intelligent systems that can respond to ever changing real world conditions. Now, after understanding the different types of machine learning, let's further dive into those categories and understand what are the further types of those supervised machine learning, unsupervised machine learning, and reinforcement learning. First conversation we will have here is the types of supervised machine learning. As previously we understood that there are three types of machine learning. One is supervised machine learning, another is unsupervised machine learning, and the next one is reinforcement machine learning. Now we'll dive further deep into the supervised type of machine learning, where we'll understand what are the different types of supervised machine learning and how they are designed. What are the components of the supervised machine learning? We'll understand that, as well as we'll understand what are the different types of unsupervised learning as well. Again, this is the introductory level video. Here we will be talking about the high level information about these machine learning models. And in the next videos, I have gone super in detail about each individual types of machine learning models including mathematical intuition and also the coding behind it, development process, and the deployment of the machine learning models. So please do not forget to check out those videos. Those are really, really helpful and informative. So, while talking about the classification machine learning, it has the classes that we need to predict. Now, the next one is the regression machine learning, where we will be predicting the continuous value or the continuous numbers. That being said, in the image, you can see that the classification machine learning uses the information, uses the data to predict the class, either that is the banana, apple, given the different features, different information about the fruit. This is one of the example. Another example can be the spam email detection. Given the information in the email, the machine learning model, the classification machine learning, will predict either that email is spam or not spam. Given the patient's information, different symptoms, different diagnostics, different situation of the health or health condition of a patient, having that info, the machine learning model will predict either a patient has the certain disease or does not have the certain disease. In the other words, it will predict is the patient likelihood of having a certain disease or does not have a likelihood of having certain disease. On the other side, regression machine learning talks about the continuous numbers, having all the information about the house, for example, number of bedrooms, number of bathrooms, number of floors, or number of hospitals nearby, distance from highway, etc. The regression machine learning will predict what is the price of the house. That's the idea behind regression machine learning. This is one of the example of the regression machine learning. Another best use case can be what is the stock price based on the different conditions of the company's operations. So these are the high level examples of the regression and classification machine learning models. Let's further dive into these individual type of supervised machine learning like classification and regression, and let's further understand about them in detail. Let's begin with understanding what is the classification machine learning by the definition and with some examples. The classification machine learning is a type of supervised machine learning where we have objective to predict the categories, the labels of new observations based on the past information that we have provided to the machine learning models. That being said, first of all, the machine learning models will be trained with the information, supportive information. For example, the independent variable, or we would say the information data, the features that will provide and will train the machine learning model, along with the label that we want the machine learning model to predict for the future data. Once the machine learning model is trained, then later trained model will be utilized to predict the labels for the data that does not have a label. And that is what is the job of the classification machine learning model. The algorithm learns from the training data set. Of course, the training data is the information that supports the prediction of the target values, which definitely contains the input data and the output, the target value that we want to predict, target classes that we want to predict, to classify the input data into predefined categories, right? So common classification algorithms include decision trees, support vector machine, logistic regression, neural networks, k-means clustering, etc. And we will dive deeper into those type of machine learning models in detail. In this video, it's going to be introductory, but next videos I have made is on each individual machine learning models. We have discussed about what is decision tree and what is the mathematical intuition behind it and how to implement that in Python programming, what are the tools you utilize to train the machine learning model and further deploy them into the production so that your business customers can use these machine learning models and make the smarter data driven decisions. Now, there are different types of applications of the classification machine learning models, such as we have already talked about the spam detection, image recognition, medical diagnostic, customer segmentation, etc. There are so many different use cases, and these are just few examples of those many different use cases that classification machine learning models have in the real world scenarios. Now, the next one we will be talking about is what are the individual classification machine learning algorithms that you can use based on the different types of problems that you are trying to solve. There are many different types of classification machine learning algorithms. I have made the list of the classification machine learning models are included here. Here are the most popular ones that is being used in the real world problem to solve the real world problem, and to make the very powerful business data driven business decisions. Logistic regression is very basic, the foundational level classification machine learning model, which predicts the binaries, two possible outcomes, either that is yes or no, spam or not spam, patient is likely has a likelihood of having disease or does not have a likelihood of having disease, etc. Support vector machine is one of the most powerful and a little bit advanced than the logistic regression. It uses many different types of non-linear functions, which is called also the kernel functions. It is a very powerful one that helps us to predict the labels from at different dimensions, not only the two dimension but more than two dimensions. Now, decision tree, here an example of the decision tree on the screenshot that I have included here. Decision tree is another powerful classification and regression machine learning type of machine learning model. So even support vector machine and support vector machine with kernel, k nearest neighbor is another one of the easy to implement but powerful classification machine learning model. Naive Bayes, random forest, and etc. Gradient boosted trees, boosting machines, AdaBoost, XGBoost. These are called ensemble techniques. Here, from the random forest up to the XGBoost, they utilized many decision trees to make the decisions, and they provide us the pretty powerful predictions as part of the classification regression problems. Now we have another yet very powerful and very popular type of classification and regression machine learning model, that is neural network. Neural network is not only used for classification and regression tasks in general, but also it is used for many complex type of problems such as deep learning and also the natural language processing, etc. So neural network is pretty powerful and yet popular and gaining a lot of popularity to solve complex business problem. There are many other type of the classification algorithms as well, and in our YouTube channel we have included so many examples, so many case studies on each individual machine learning classification and regression machine learning algorithms. Please do not forget to check out those, they are really really helpful. Now, next we will be talking about is the regression machine learning. What exactly is the regression machine learning? Regression machine learning is the type of supervised learning, again, because we are now talking about the supervised machine learning, where our objective is to predict the continuous numerical value. Here, earlier we talked about predicting for classes given the input features. Now here the target is to predict the continuous value instead of the class. So here the examples are slightly different. Unlike classification, which deals with the discrete labels, regression models aim to establish relationship between the dependent and independent variable to forecast outcome. That being said, it looks at when the value of x increases, then does the value of y also increase or decrease? And that's how we look at the relationship between the feature, between the information provided against the target variable that we want to predict. For example, given the company's assets, if the company's asset increases, does the stock price also increase? Given the revenue of the company decreases, does the stock price decrease? etc. So that's the idea behind looking at the regression type of machine learning algorithms, regression type of machine learning, which is responsible to predict the continuous value instead of the categorical value that classification type of machine learning model does. Now there are different type of regression machine learning models, which includes the linear regression, polynomial regression, decision tree regression, neural network regression, etc. There are so many, support vector regressor, k nearest neighbor regressor. There are many different type of regression machine learning models as well. However, we will dive deeper into those individual regression machine learning models into our next videos, and we have made so many videos on the use cases, actual implementation of those machine learning models into different data sets available throughout the industry. So please do not forget to check out those. Regression machine learning has many type of applications, many wide variety of applications in different industry, from finance to economics, real estate area, healthcare, automotive, and so on and so forth. It has a wide variety of applications, and you may definitely want to learn in depth about those individual regression machine learning models for your successful journey into the data science and machine learning. Now the next we will be talking about is what are the different type of regression machine learning algorithms. What are those models that do the job of predicting the continuous value given the input features? Here are the list of some of the machine learning models that do predict the continuous value. Such example, simple and multiple linear regression. Simple linear regression would have just one column of the feature, and we have another column of target variable that we want to predict. And the multiple linear regression is, we have the many features or many predictor variables, and we will be predicting the target variable, that is the continuous value. Polynomial regression is another one that is very powerful one, when we have the exact non-linear relationship between the independent variable or training features against the target variable. Region lasso regression is used to penalize the weights when we have the overfitting problem, and we will be talking about overfitting things into our next videos, and we have explained in detail about what is region lasso regression, how they help us to reduce the overfitting or noise capturing situation, and how they help us to make the model accurately predicting the values for unseen new data as well without having labels. Now Bayesian regression, principal component regressor, or support vector regressor, decision tree regression, and random forest gradient boosting neural network regression, these are the examples of the regression machine learning algorithms. They help us to powerfully predict the continuous values given the input features or given the predictive variables. Now these are just some of the visuals that I have included from my own machine learning models that I have developed and have experimented the success of all of these machine learning algorithms, that they help us to powerfully predict the output values given the input features. Now, the next one will be talking about the unsupervised machine learning. Before starting unsupervised machine learning, I want to give you again heads up that this is the introductory level video. Here we'll be talking about at a high level introduction of each individual types of machine learning models, including their categories, etc. And in our next videos, I have uploaded in-depth walkthrough about each individual machine learning models using the mathematical intuition, case studies, and practical deployment of the machine learning models into the web applications. So please do not forget to check out. Again, if you have not subscribed my YouTube channel, please do not forget to subscribe the YouTube channel so that you get updated with the very recent information that I keep sharing every maybe week or very frequently in my YouTube channel, that may help you to learn a lot into the world of data science, machine learning, and AI. Now, that being said, let's learn about what are the different types of unsupervised machine learning. We just learned about the supervised machine learning, which has classification and regression capabilities. Now we'll learn about what is unsupervised machine learning and what are the different types of unsupervised machine learning. The first type of unsupervised machine learning is clustering. Clustering is the idea behind grouping the data based on the similarity. We'll be talking about that in the next slide. Here, the next type of unsupervised learning is the dimensionality reduction. Dimensionality reduction is simply if you have so many features in your data, and a lot of features may not necessarily help the machine learning models to be better. Many of the time that data may have a lot of noisy information, a lot of unhelpful information. So you may want to reduce that noisy features and get only the valuable features that will help you to get better accuracy out of the model. So that's the idea behind dimensionality reduction. So we try to reduce the dimensions, reduce the features while retaining most of the information that is in the data set. So let's dive into those individual type of unsupervised learning, and let's understand individual of those. And one of the another type of unsupervised learning is anomaly detection. So using unsupervised learning technique, we try to identify if there is any anomaly within the data that is unusual, that is not of the similar trend as what rest of the data is. That's the idea behind anomaly detection. Let's understand about each individual type of unsupervised machine learning.